Good morning. This is the ELL101 project by Abhilasha Das, 2021 EE10168. The topic of this presentation is electronic thermometers, which makes use of op-amps and silicon diodes in its internal circuitry. Op-amps are multi-stage high-gain amplifiers having a differential input and single-ended output which draws power from an external supply voltage. It contains several transistors, resistors, a few capacitors and diodes in its internal circuitry. A diode is a two-terminal electronic component which conducts current primarily in one direction. It has low resistance in one direction and high resistance in the other. Here, it is used as a temperature measuring sensor. There are quite a lot of applications of diodes and op-amps. Diodes are used for radio demodulation, power conversion, reverse and overvoltage protection, for temperature measurements as waveform clippers and clampers, and for current steering. Op-amps are used in electronic system design, voltage comparators, positive and negative feedback applications, filters and peak detectors, and much more. Here, we'll be talking about the use of diodes for temperature measurement and op-amps as a temperature to voltage converter and voltage amplifier. Op-amps as voltage amplifiers. There are two main circuits of op-amps being used as voltage amplifiers. The inverting operational amplifier. In this case, the op-amp forces the negative terminal to be equal to the positive terminal, which is commonly ground. Therefore, the input current is determined by the V in by R1 ratio. Here, the gain of the amplifier is minus R2 by R1, and thus the V output is given by minus R2 by R1 into V input. Non-inverting amplifiers. In such a case, the input signal from the source is connected to the non-inverting, that is the positive terminal. In this case, the gain of the amplifier is 1 plus R2 by R1, and thus the V output is given by 1 plus R2 by R1 into V input. A thermometer is a device which measures the temperature or the temperature gradient. A thermometer has two important elements: a temperature sensor in which some change occurs with a change in temperature, and the second one is some means of converting this change into a numeric value. An electronic thermometer works by using heat sensors which determines the body temperature. It has a diode which acts as a temperature sensor and provides a feedback path, and an operational amplifier which converts the temperature to voltage. The working of the electronic thermometer. As we can see in this given figure, the entire circuit of the electronic thermometer is built around two operational amplifier 741 IC, the silicon diode, and a few passive components. Here the silicon diode D1 is used as a temperature sensor. How does a diode help in temperature measurement? A diode can be used as a temperature measuring device since the forward voltage drop across the diode depends on the temperature as a silicon band gap temperature sensor. From the ideal diode equation I equal to Is e to the power Vd by eta Vt minus 1, it might appear that the voltage has a positive temperature coefficient, but usually the variation of the reverse saturation current is more significant than the variation in the thermal voltage term. Thus, most diodes have a negative temperature coefficient. The actual working of this electronics thermometer can be understood in two phases. Phase 1. Here, the op-amp IC1 works as a temperature to voltage converter, whereas the sensor diode D1 provides a feedback path. Thus, the output of the op-amp is variable. It depends upon the voltage across the diode, which eventually depends on the temperature. The non-inverting pin of the op-amp IC1 is maintained at a constant voltage by VR1, R1, and R2. The second phase. The op-amp of the output of the first op-amp IC1 is connected to the input of the second op-amp IC2, which works as a voltage amplifier. The gain is adjusted by VR4 in such a way that the voltage change of 2 mV at the pin 2 of IC2 causes an increase of 10 mV at the output. The output is observed at the analog meter and its sensitivity is adjusted by the VR3. The meter readings can be adjusted by keeping the diode at various known temperatures. Thus, this was the working of the electronic thermometer, in which the first op-amp acted as a temperature converter, and the second op-amp acted as a voltage amplifier. There are quite a lot of advantages of the electronic thermometers. They can read the temperatures fast and with high accuracy. They are handy and easy to use as we do not need to worry about the mercury bulb breaking. The display is easy to read and they do not require any special maintenance. Thus, with this presentation, I have tried to show the basic idea on how an electronic thermometer actually uses a complex circuit of silicon diodes, capacitors, op-amps, and resistors at its base. This thermometer has many advantages over the mercury-based ones and are rapidly gaining popularity. These are the references which I used in making this presentation. That was all in this presentation.